Hi everyone, welcome back to my YouTube channel. This is my third video on design pattern. So if you haven't watched the first and second on singleton and builder design pattern, I will link and you can watch that from the starting. So in this video, we will be learning about factory design pattern. I will walk through an example and what are the problems in that example, and later we will solve that problem through a factory design pattern, because learning when to apply is more important than how it is implemented. So the problem is we have a notification service and it has a method which is to notify the customers. So it has two arguments or two parameters, you can say. Uh, First is the notification type and second is the message. So notification type tells you what type of notification you want to tell, and message is the message you want to send in the notification. So here we are creating the notification object based upon the type of notification, and later we are calling the notify users. So now let's say we now support Slack based notification as well. So we have to go and update the code and as Slack based notification as well. The rest of the code remains same. Now let's look at the problems which are there in our current code. First is the violation of open close principle. So open close principle says that your class should be closed for modification but open for extension. So close for modification means like I have created this class, like, but if I have to add a new functionality, I have to modify it. So this shouldn't be the case, and so that's why it violates open close principle. It should be open for extension, like at the runtime we can add new functionality or modify new functionality, but it should be closed for modification. Second is it has dual responsibility. First responsibility is to get the type of notification object we want to support or call, and second is to actually calling the notify user on top of it. So it's also violates single responsibility principle. So let's fix all this problem one by one. So uh, what we can do is, the first thing which we need to do is, like, this is a variable portion, right? So whenever a new type of notification comes, this portion changes. So now this portion changes, so that's why we have to solve the close for modification part. So what if we can delegate the construction of object to a different class? So after delegating, let's say we have a notification vector, will come to its implementation later, but let's say somehow we have created this class and we have a get notification service, and what is a variable which we require to get that notification service is a notification type which we are passing in that function. So once we have passed notification factory, let's say it magically returns us the type of notification object, and then we can simply call the notify users. So it solves the problem of open close, since now if you have to add a new type of notification, you have to go and update this class, not the notification service. So it solves this problem. It now has single responsibility principle as well, and obviously double responsibility is eradicated since it now has a single responsibility. Now our problem remains, like, how to implement this part. Now it was just a movement of the code. Let's see how the factory looks like. So we have encapsulated the creation of notification to a separate class. So that's why we call it factory, because it's creating the object and it's a creational design pattern. So this is how factory looks like. So it has a similar code which we looked earlier, but now the creation is delegated to a factory. So this code solves our all the problems. So now look at the factory design pattern UML diagram. So notification service has a notification factory. So it has a get notification which will return the type of notification we want, and also it can have a registry. So let's say in the previous example, we are creating the notification object every time. Uh, if it is independent of if we can solve the purpose with one object, like for each customer we can have just email notification one instance, we can have the singleton object for that as well. So we can have a map registry in that case, and can return from the map the type of notification object. So we have to create email notification just one, SMS notification just one, instead of creating every time we ask from the factory. So it has a notification factory whom we delegated the creation of object. Then it has an interface. It has interface of notification. Why we have interface? Because every notification should be of a base type to be used in the parent class. So it should have, so everything this should extend notification or like implement, they should also so that the parent doesn't have to change, it's compatible with any of its subtype. So now notification factory returns notification, and it has email notification, SNS notification, WhatsApp notification, and Slack notification. So this is a factory design pattern. So we can now see the official definition of it. So the factory design pattern defines an interface. So it's define an interface which is used for creating an objects, but let subclasses decide which class to instantiate. So factory design pattern lets class defer instantiation to subclasses. So this is the implementation of factory design pattern. So that's it from this video. Next video will be on abstract factory design pattern. Thank you.